Here in the current video I am going to discuss about the Faraday's first law of electrolysis. This subpoint deals with the topic electrochemistry. Electrochemistry is the branch of physical chemistry which deals with the study of relationship between electrical energy and chemical reactions. So by certain chemical reactions electrical energy can be generated, and by using the electrical energy certain chemical changes can be carried out. So both the types of convergence, electrical into chemical and chemical into electrical, that study is carried out here in the electrochemistry. And the today's topic of discussion is the Faraday's first law of electrolysis. The laws which governs deposition or liberation of substance over the electrode when electric current is passed through the substance are nothing but the Faraday's laws of electrolysis. In simple words, what it means? It means that during the process of electrolysis over the electrode, the substance is either deposited or that substance is liberated in the form of gaseous. In the gaseous state, that substances get liberated. So this occurs, this governs, this process occurs, and there is a certain quantitative relationship between the parameters of this change, means how much quantity of electricity we are giving, what is the equivalent weight, how much amount of the substance will be deposited, liberated. So these are the some variables, and there is a certain relationship between these variables that was found by the scientist Faraday. Okay, there are the two laws of the electrolysis which was given by the Michael Faraday, and we are going to discuss, that is the Faraday's first law of electrolysis. The statement, okay, when weight of substance, I'll write here, weight of substance liberated or deposited at an electrode during electrolysis is directly proportional to quantity of electricity pass through it. This is the statement, very simple. Two variables are discussed. First one, which one? That is nothing but the weight of substance liberated or deposited. Okay, I'll write here, that is W, weight of substance liberated or deposited, and that is directly proportional to the what? Directly proportional to the quantity of electricity. W is directly proportional to the quantity of electricity. Very simple variable. Okay, say for example, how much work someone did. Okay, how much energy I have, that is going to say get utilized for the doing different acts, isn't it? Here weight of substance is directly proportional to the weight of substance liberated. See, for example, here we have the pot, we have kept here the silver bar, Ag silver bar we have kept, and here I am showing spoon, steel spoon, iron spoon is kept. Okay, these are the two electrodes connected to each other. Externally there is a key and there is a battery. Okay, negative, positive. Okay, voltmeter also you may show here. So what happens? I hope you are understanding. This is the silver rod and this is the steel spoon. And electrolyte, here we are using the electrolyte consists of the Ag plus ions, silver ions like potassium, argentocyanide, potassium cyanide, potassium nitrate, something potassium ion containing electrolyte we have used. What happens when we press the key? Electric current start to flow, and these positive ions will move towards the negative electrode. Here it is the negative electrode is the steel spoon. It is connected to the negative pole of battery. what will happen? These positive silver ions start to deposit over this electrode. Okay, that mechanism differently we can discuss in detail, but just I want to tell you here what happens during electrolysis. That certain substance, that substance start to get liberated or deposited. Here I give the example of deposition of silver. Silver is there in the form of ions in the electrolyte. Now that silver is going to deposit. Now what this first law of electrolysis states, it states that weight of substance is directly proportional to the quantity of electricity, isn't it? Suppose more and more electricity we are passing, so more and more silver will be deposited. Of course, unless and until the whole amount of the silver will get deposited, the process will goes on. Okay, I hope it's easy, you understood. Weight of substance is directly proportional to the quantity of electricity. Let's proceed. Beside this, here quantity of electricity we have written Q, and that quantity of electricity is nothing but the current strength in ampere. I'll write here quantity of electricity, that is Q, is nothing but the current कम हो रहा है, current कम current strength in ampere into time in seconds. Okay, so that is the relationship. Quantity of electricity is different one, current strength in ampere is, current strength is different, and time is different. Here the relation given is, suppose if we pass 1 ampere current for 1 second, then the quantity of electricity is 1 coulomb. What is the meaning of 1 coulomb? When 1 ampere current is passed for 1 second, then collectively the quantity of electricity is said to be a 1 coulomb electricity. I hope it is clear. Now here next one, what is the charge of single electron? Single electron correspond to the charge 1.6022 into 10 raised to minus 19 coulomb. In atomic structure we have studied. Okay, don't consider the magnitude plus minus. Here charge, that sign plus minus, one single electron carry charge 1.6022 into 10 raised to minus 19 coulomb. Correct? Now what is the charge over the 1 mole of electron? 1 mole of electron means how much? 6.022 into 10 raised to 23 electrons. What is its charge? So whatever the charge of single electron into 1 mole, 1 mole is nothing but the 6.022 into 10 raised to 23, that much coulomb, and it is nearly 96,500 coulomb. Okay, 96,000 somewhere 484, 96,514 something given, but we took value 96,500 coulomb. I hope you understood. Single electron will carry this much charge, and 1 mole of electrons will carry the 96,500 coulomb charge, and that is nothing but the 1 Faraday. Okay, so quantity of electricity can be measured either in coulomb or in Faraday. Correct? So this is the one thing. Now next one, how this Faraday, coulomb, they are related, and what is our main statement, that also we have to see. Okay, little weight it is. Yes, let's proceed. Here 1 Faraday is nothing but the 96,500 coulomb. This is the one thing. Let's come to our original point. What we discussed, that as per the Faraday's first law of electrolysis, weight of substance is directly proportional to the quantity of electricity. But just we saw that quantity of electricity is nothing but the current strength in ampere and time in second. Correct? So here it becomes W is equal to ZIT. What is the Z? Z is nothing but the electrochemical equivalent. electrochemical equivalent. Correct? That is the Z. Let's see in here. Suppose if we pass 1 Faraday electricity. Okay, 1 Faraday electricity means what? 96,000 coulomb electricity if we pass. And just imagine the weight of substance deposited is E gram. Okay, actually it is when 1 Faraday electricity is passed, weight of substance deposited will be equal to its equivalent weight. Okay, now what that is said in the second law, but just now you consider E gram of the substances get deposited. Correct? Now second thing here, 96,500. Yeah. Now the second thing is, if we pass 1 coulomb electricity, okay, if we pass 1 coulomb electricity, whatever the substance liberated or deposited, that is nothing but the, you may say, x gram, but actually it is the z gram of the substances get deposited. What I am telling, what is the meaning of electrochemical equivalent? Electrochemical equivalent is nothing but the weight of substance liberated or deposited when 1 coulomb electricity is passed. Okay, either in some case there may be a deposition of silver, in another case there may be a deposition of copper, zinc or hydrogen gases to be released, irrespective of the substance. If 1 coulomb electricity is passed, then weight of substance liberated or deposited equal to its electrochemical equivalent. Okay, so now students, what is Z? Can you tell me by the cross multiplication? 96,500 coulomb correspond to the E gram, 1 coulomb correspond to the Z gram. Z is nothing but the electrochemical equivalent. So what is Z? Z is equal to 1 coulomb into E. Okay, E into 1 coulomb divided by 96,500 coulomb. So coulomb get cancelled. So here E is equal to Z is equal to E by 96,500. Okay. Now this we have to put here in this equation. You may call it as equation number 1. What is the value of Z? E by 96,500. So I will put here. So this equation will become W equals to, instead of Z, what should I write? E by 96,500 I into T. Correct? So W upon E. Okay. So E, when it comes to the LHS, it becomes W by E, which is equal to IT upon 96,500. IT upon 96,500. Okay, so these are the different conversions, but here the main summary of the Faraday's first law of electrolysis, it is in front of you. Weight of substance is directly proportional to the quantity of electricity, that is directly proportional to the current strength in ampere into time, which is equal to the W is equal to ZIT. Z is electrochemical equivalent. Let me tell you the one major final trick. Okay, we know that quantity of electricity can be measured either in coulomb or in Faraday. Correct? So what is the relationship between that two? Here it is written 1 Faraday is nothing but this much coulomb. So when 1 coulomb electricity is passed, weight of substance liberated or deposited equal to its electrochemical equivalent, that is Z gram. And when 1 Faraday electricity is passed, weight of substance liberated or deposited equal to its equivalent weight. This is the major point. Okay, applicable for the you are going to deal with the different substances. So at that time it will be useful. 1 coulomb correspond to the Z gram of the substance. Z means electrochemical equivalent. Okay. Here I kept few numericals. Okay. So let's start to see them. First numerical is, let's see what is here. I'll write here. The first numerical is from the values of Faraday. Faraday, what is the value of Faraday? Is nothing but the 96,500 coulomb. And Avogadro's number. What is the Avogadro's number? That is 6.022 into 10 raised to 23. From the values of Faraday and Avogadro's number, calculate the coulombic charge of an electron. What is the coulombic charge or charge of one electron? Single electron is how much? That we have to determine. That is the question. Simple question we have. I have chosen first of all. So here, let me write here. That is 1 mole of electron, 1 mole of electrons, how much? 6.022 into 10 raised to 23 electrons correspond to the how much charge? 1 mole of electron correspond to the 96,500 coulomb charge. So what is the charge of single electron? Just we have to do the cross multiplication. I hope you understood. Okay, so single electron will carries x coulomb charge. So what is the x? X is nothing but the, let's do cross multiplication. 96,500 into 1 divided by 6.022 into 10 raised to 23. So it can be written as 9.65 into 10 raised to 1, 2, 3, 4 divided by 6.022 into 10 raised to 23. So it can be written as 9.65 divided by 6.022 into 10 raised to 23. When it goes to the numerator, it will become 10 raised to minus 23. Minus 23 plus 4, so it becomes minus 19. Okay, so 9.65 upon 6. Okay, not 22 is also there. So you will get the answer 1.6022 into 10 raised to minus 19 coulomb. This is the charge of single electron. Okay, actually this is the known fact. Okay, single electron carries this much charge, 1 mole of electron carries this much charge. Okay, known fact, but in this form also the question may asked. Let's have another question. Now please. Let me put here. The another question is find the charge in 1 coulomb of 1 gram ions of nitride. What is the charge of 1 gram ion? 1 gram ion of n minus 3. How much charge it carries? 1 gram ion of the nitride we have. Actually in the question one thing is missed, that is 1 gram equivalent. 1 gram equivalent ion of the nitride we have, n minus 3, and how much charge it carries. Okay, so let's see here. Tell me how much charge you are seeing over the nitrogen in nitride ion. It carries a minus 3 charge. So 1 nitride ion carries 3 into single minus 1 correspond to the how much charge? Minus 1 correspond to the 1.6022 into 10 raised to minus 19 coulomb charge. Am I correct? I hope it is clear. N minus 3. Single minus means 1.6022 into 10 raised to minus 19. So 3 minus charge is there. So that's why this is 1. Okay. And 1 gram equivalent means what? Actually 1 gram equivalent, that is nothing but the 1 mole. So 1 gram equivalent nitride ion means 6.022 into 10 raised to 23 nitride ions. I hope you are getting. Single nitride ion carries this much charge. Here the question is how much 1 gram equivalent nitride ion will carry how much charge. So I'll write here charge over 1 gram equivalent nitride ion will be. So 1 gram equivalent nitride ion is nothing but the 6.022 into 10 raised to 23 into charge over the single nitride ion is 3 into 1.6022 into 10 raised to 23. Sorry, 6.022 into 10 raised to minus 19. Correct? So ultimately we have to do multiplication of all these one. Okay. So into 10 raised to 23, 10 raised to minus 19. So it becomes only 10 raised to 4. And 3. So it's a 4.8. Okay, now this multiplication I did here, it's a 4.8. 4.8 into 6.022. Correct? So let's see. 288 into 10 raised to 4, and the point should be here 28 2.88 into 10 raised to 5, 2.88 into 10 raised to 5 coulombs. Yeah, okay, so that is the correct answer. uh, so this fraction in the fast calculation, no need to think I chosen here 1.6 or 6 only I choose here. So answer they have given 2.89, which is almost correct. 10 raised to 5 is there. Okay, so 1 gram equivalent of the nitride ion will carries this much charge. Okay, so the summary is what? Weight of substance liberated or deposited is directly proportional to the quantity of electricity. More the quantity of electricity we pass, more of the substance will get deposited. Okay, bye, thank you.